Let's take a look at linear inequalities and absolute value inequalities. First, let's review our set builder, interval, and graphs of the different forms. We have our first one, which is x is less than 1, and then our set builder is easy. Our set builder, you put curly brackets around it, you put an x, you put a vertical bar, and then whatever you came up with over there. Now how you read that is this is a set of all x values. That vertical bar is such that x is less than 1. Now for our interval notation, x is less than 1, which means it's going to negative infinity. And negative infinity is a very small number you never reach because you can keep subtracting 1. And then 1 goes here, and its x is less than, so I'll put parentheses, so parentheses means it doesn't include it. And then our graph, we have 1, and then parentheses on it, and then we're shading to the left, going to negative infinity. We have x is less than or equal to 2. Now I'm putting numbers here just so we can see it instead of putting like a's and b's, but you can have any number there. And again, this will be easy for set builder. It'll be a set of all x values such that x is less than or equal to 2. Now it's going to negative infinity again. And I put a 2, and since it's less than or equal to, then we put a bracket. Now bracket on 2 there, then bracket on 2 here, and again it's being shaded to negative infinity. Now we have x is greater than 5, for example. This is our set builder. And then have parentheses on the 5, and it's going to positive infinity. And again, parentheses on a 5, and it's shaded to positive infinity. And then we have x is greater than or equal to, 10. You can have any number there. Greater than or equal to. Bracket on 10 because it's a greater than or equal to, and it's going to positive infinity again. Like that. Now, if it's between two values, like x is between 1 and 2, again, set builder is very easy. Put x with a vertical bar, and then 1 less than x less than 2. Now, it'll be parentheses 1 comma 2 parentheses. Parentheses because these are both less thans. Less thans means it doesn't include a number, which is parentheses. And then I have parentheses on 1, parentheses on 2, and shade in between them. Now, if you have set builder, the graph is very easy. You know, parentheses on the 1, parentheses on the 1, parentheses on 2, parentheses on 2. And then you shade them. Let's see. 3 is less than x is less than or equal to 4. Again, set builder is very simple. Interval is a little harder, but less than on the 3 means parentheses. Less than or equal to on the 4 means brackets. Then our graph, parentheses on the 3, brackets on the 4, and shade in between. And less than or equal to there, and then less than here. Set builder would look like this. Bracket on the 7, parentheses on 10. There we go. And one last one. Less than or equal to is on both of them. So we got x such that this is true. And then bracket on both of them. And on a graph, bracket on both of them. That'd be your answer. Or an answer. That would be our form. Now let's look at our first problem. Excuse me. I knew it was coming. I just kept waiting. Okay, express each interval in set builder and graph. Well, here we have two numbers. Then we have bracket and parentheses. So I come up here. The ones that are two numbers are these bottom four, and I'm looking for a bracket parentheses, which would be the 7 and 10 form. So it's going to look like that. It wants set builder, so I come over here. This is what my set builder is going to look like, but instead of 7 and 10, I'm going to have negative 2 and 5. So this would be x such that negative 2 less than or equal to x less than 5, like that. Now in terms of our graph, if we come over here, it'll look like this graph over here, but instead of 7 and 10, we're going to have negative 2 and 5. Now until you get comfortable with interval notation and all those, I would use that table. You should eventually get to the point where you won't need to look at that table. You recognize that a bracket is the same as a less than or equal to. A parentheses is the same as a less than. And it's very easy if you have interval notation. See a bracket on negative 2, bracket on negative 2. Parentheses on the 5, parentheses on the 5. But those would be our answers for the first example. Okay, our second one. Got negative infinity and then 4. Okay, so we got negative infinity on the left side. We got parentheses around both of them. So we come up here. Negative infinity on the left side, parentheses around both of them. It matches this first form. Set builder would look like this. And instead of a 1, we're going to have a 4. So this would be x such that x is less than 4. And if I looked at my graph up there, I'd have parentheses on a 4, parentheses on a 4. It's shaded to negative infinity because it's going to negative infinity, like that. And those would be our answers. Now the next two kind of go together. So let me put it. We got negative 5, 2, intersection, negative 3, 4. And our next one is negative 5, 2, union, negative 3, 4. Now this symbol right here is intersection. Not that I can spell. Well, that's bad. Let's try it again. Intersection. Now, graph-wise, intersection is the AND statement. Or math-wise, it's the AND. Now, graph-wise, this is where they are both shaded. So where they are both shaded. Over here, this symbol here is our union symbol. And this is the OR in math. Now, graph-wise, this is where anything is shaded. So that's where anything is shaded. Well, let's first draw the big graph, and then we'll write the answers down of each individual one of these. Smallest number is negative 5, and negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. Okay. So I got negative 5 to 2. So parentheses on negative 5, parentheses on the 2, and I'm shading in between them like this. The other one is negative 3 to 4. So I'll do bracket negative 3 to 4, like that. And then I'll shade in between them. There we go. Okay, now let's write our answers down. Our first one here, the intersection of these. Graph-wise, there's where they are both shaded. Well, these are both shaded from negative 3 to 2. And bracket on negative 3, bracket on negative 3. Parentheses on 2, parentheses on 2. So whatever symbol's there, you just carry down. Now this one is where anything is shaded, the union. So where anything is shaded is from negative 5 to 4. Parentheses on negative 5, bracket on the 4. And those will be our answers for those two. Now see, it says use graphs to find each set. Again, it's best to visually look at this. What they're getting ready to point out to you is that later on when we're dealing with absolute value inequalities, sometimes it's hard to understand how they get their answer unless you look at the graph. And then if you look at the graph, it makes perfect sense why it comes up with what they do. So let me save this page. Take a drink also. So CA linear and absolute value inequalities. Page 01. Next ones are linear inequalities. The next 1, 2, 3, 4, I guess. Yeah, next 4 of them. So let's take a look at how to solve a linear inequality. We have our note up at the top. It says at any step, combine like terms and combine numbers. Step 1, get rid of parentheses. And remember, we do this via the distributive property. Step 2, get rid of fractions. And we'll do this by multiply everything by the LCM of all the denominators. Step 3, get everything with an X. On the left side, numbers on the right side. Now the reason why I say left side and right side on that is then it'll match our forms exactly on that table I first put up. So until you get comfortable with it, I would stick with that. And then the fourth step, divide both sides by the number in front of the X. We have a note that goes along with this that says if you multiply or divide both sides by a negative number, flip the inequality symbol. So flip the inequality symbol. Now let's take a look at some problems. We got 3x minus 2 is less than 13. Okay, first step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Don't have any. Third step, get everything with an x on the left side, numbers on the right. So I'll take negative 2 over to the right side. Now, just like when we're dealing with the equals, when you take anything across your inequality symbol, the sign changes. The negative 2 becomes a positive 2. Our note up at top and any step combine together like terms. 13 plus 2 is 15. And last step, divide both sides by a number in front of your x. So we're going to divide both sides by 3. So these cancel. And we got x is less than 5. Now, it says, other than use interval notation, express solution set, graph it. For interval, its x is less than negative 5, so it's going to negative infinity. And it's less than 5, doesn't include 5, so put parentheses on it. And parentheses on the 5, parentheses on the 5, and shading to negative infinity. Let's take a look at this one. We got 10x plus 35. It's less than or equal to 4x minus 11. Now, first step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Don't have any. Third step, get everything with an x on the left side and numbers on the right side. So I'll take 4x over the left side and 35 over to the right side. Anytime you take anything across your inequality symbol, the sign changes. So 4x becomes a negative 4x. The 35 becomes a negative 35. Combine together like terms at any step. 10x minus 4x gives us 6x. It's less than or equal to negative 11, negative 35 is negative 46. Last step, divide both sides by a number in front of your x. So we're going to divide both sides by 6. Those 6's cancel. Now notice I didn't flip my inequality symbol, did I? I'll talk more about that here in a second. 46 and 6 are both divisible by 2 at least. That's negative 23 over 3. And that looks like our answer. Interval notation, it's going to negative infinity. Less than or equal to, so it includes the negative 23 over 3. So I'll put a bracket on it. Graph-wise, bracket on negative 23 over 3. Down here, bracket on negative 23 over 3. And I'm shading it to negative infinity. Okay, now I said that when I divided by 6, I didn't flip the inequality symbol. But that's a negative 46. But look what this says. If you multiply or divide both sides by a negative number, so we're talking about the number down in the denominator, the 6, that we're dividing by a positive 6. So that's why we don't flip the inequality symbol. A lot of people see negatives, and anytime they see it, they start flipping the inequality. Let's take a look at the next example. So we got negative 8 times x plus 3 is greater than 3x plus 20. Okay, first step, get rid of parentheses. Well, I'm going to take this negative 8 and multiply it times the x and times the 3. Negative 8 times x is negative 8x. Negative 8 times 3 is negative 24. Now, we didn't flip our inequality symbol. I think that's a 20. Let me look. Yeah. We didn't flip our inequality symbol. That's where you go and multiply both sides by a negative number. Well, this negative 8 was already in our problem, and besides that, it's only multiplied by a little piece. Okay, third step. Get everything with an x on one side and numbers on the other. So I'll take 3x over the left side, negative 24 over here. I think I said that wrong. But get everything with an x on the left side, numbers on the right. So I got negative 8x minus 3x is greater than 20 plus 24. Anytime you take anything across your equals, sign changes, or across your inequality. Negative 8x and negative 3x gives us negative 11x. 20 plus 24 gives us 44. Last step, divide both sides by a number in front of your x. So we're going to divide both sides by negative 11. Now we're dividing both sides by a negative number, so our greater than becomes a less than. We flip our inequality symbol. And we got x is less than negative 4. That's going to negative infinity. Less than negative 4 means it doesn't include negative 4, so I put parentheses on it. And parentheses on negative 4 down here, shaded to negative infinity. Let me get a drink and then save this one. And let's look at this one. We got 3x plus 2 over 3x minus 2. So 3x minus 2 over 5 plus 2 is greater than or equal to 4x minus 1 over 15. Now our first step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all our denominators. Now we got 5 and 15, so our LCM is 15. So multiply everything by 15. So multiply the first fraction by 15, multiply the 2 by 15, and then the fraction on the right side by 15. Now 5 and 15 both divisible by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. 15 and 15 both divisible by 15. 15 divided by 15 is 1. 15 divided by 15 is 1. If you end up with all 1s in your denominator, you pick the right LCM. Well, I got 3 times 3x gives us 9x. 3 times negative 2 is negative 6. 15 times 2 is 30. And 1 times anything doesn't change it, so that stays as 4x minus 1. At any step, combine together the numbers. On the left side, negative 6 plus 30 gives us 24. Now, third step says get everything with an x on the left side, numbers on the right. So I take the 4x to the left and 24 to the right. So we get 9x minus 4x is greater than or equal to negative 1 minus 24. Combine together like terms at any step. 9x minus 4x is 5x. Combine together numbers. Negative 1, negative 24 is negative 25. Last step, divide both sides by a number in front of your x, which is a 5. Those 5's cancel. And we got x is greater than or equal to negative 5. Now it's going to positive infinity, and it's greater than or equal to, so it includes negative 5, so let's bracket, like that. And then bracket on negative 5, and shaded to positive infinity, which is to the right. Get a drink here. Okay, let's look at a linear inequality with 3 sides. So solving a linear inequality with 3 sides. Those are referred to as compound inequalities, but there's 2 different types of compound inequalities, so I want to put that in this manner. Okay, now at any step, combine together like terms, combine together numbers. I want to write that down. First step, get rid of parentheses. Second step, get rid of fractions. Third step, get everything with an x in the middle. numbers on the other two sides. And step 4, divide all three sides by the number in front of the x. Now we still have our note here. Says if you multiply or divide all three sides by a negative number, flip the inequality symbols. Let's take a look at a problem dealing with these steps. Okay, so we got 8 is less than or equal to 2x minus 4 is less than 23. Okay, it's a linear. We got x to the first power, and we got three sides. Again, this is called a compound inequality. Now, first step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Don't have any. Third step, get everything with an x in the middle, numbers on the other two sides. So I'm going to take the negative 4 over to both the other sides. So this can become 8 plus 4 is less than or equal to 2x is less than 23 plus 4. Now at any step combine together numbers. 8 plus 4 is 12. And 23 plus 4 is 27. Last step, divide all three sides by the number in front of your x, which is 2. So I divide that by 2, and this by 2, and then the 27 by 2. Well, 12 divided by 2 is 6. Those 2's cancel, leave me x, and then 27 over 2 there. Now they don't say how to write their answer, so I'm just going to leave it that way. But it could be interval, set builder, graph. It's hard to say. I always hate when they're not very clear on how they want to answer. Let me save that. And then we'll look at absolute value inequalities.